Number 11, a trebuchet, catapult thing, launches a projectile on a parabolic arc at a velocity of 35 feet per second. So that 35 feet per second, the 35 is going to go right here in place of v. Using the function blah, your vertical motion formula, determine when the projectile will first reach a height of 80 feet and how many seconds later will it again be at 80 feet. So this is similar to the last one with the cloud cover. Very, very similar. So let's think about it. Let's go ahead and plug in our parameters. So h of t equals negative 16t squared plus 35t plus 0 because the starting height is 0. So it's going to look like this. Catapults up there, okay. Now, it wants to know when this projectile will first reach a height of 80. So just like the last one with the cloud cover, we're thinking, okay, 80's got to be somewhere right here. And we want to know when it first reaches 80. Here is what it's asking for, when it first reaches 80. And then how many seconds later will it again be 80 feet? So there's two things we're answering here. We need to find this t sub 1. That's the first answer. Determine when the projectile will first reach a height of 80. So we need to find that, and that will answer, this t sub 1 will answer this. Okay, when will it first reach a height of 80? But then it says, and how many seconds later will it again be 80 feet? So we're going to have to find this. But to answer the second question, we'll have to do t sub 2 minus t sub 1 to answer the second question. All right, so hopefully you know the setup by now. In y1, we will put negative 16x squared plus 35x. In y2, what will we put? What height do we desire to know about? 80. So let's do it. So we go to y equals, we clear out whatever's in there. We type negative 16x squared plus 35x. Oh, remember this was a typo. This is supposed to be 135 right here. So 135, 135. Let me go ahead and fix that. I told you that in class. I just forgot it right here for a second. And then in y2, I'm going to put an 80. And I want us all to hit zoom 6. So we're on the same viewing window. Again, you're going to think something's weird because you only see part of this parabola. Well, let's think about it. We're in a zoom 6 window, a standard window. We've got to get up to at least 80. So I need to go to my window. So I want you to go to window. And let's change what? Let's work with y max first. I would make y max 100. I always go about 10 or 20 above what we're looking at. So y max down here, I'm going to make 100 because we are looking at 80. And I'm just going to hit graph and see what it looks like. Gives me everything I need. Yes, I know that I cannot see the top of that parabola, but that is a-okay. I need this t sub 1, I need that t sub 2. So what do we do now? We hit second, calc, intersection. I've gone over this and over this and over this, so I hope that you understand. Second, calc 5, hit the up arrow so you can see Blinky, and then move Blinky right on top of the intersection point that you're trying to find. I always go with the left one first. So Blinky Man's right there. I hit enter 3 times, and I get that this occurs at a time of 0.64, and of course the y value is 80 because that's how we made it all happen. Okay, now I'm going to do the whole process again. Second, calc 5, hit the up arrow, move Blinky way over here on top of the other intersection point, and hit enter 3 times. And I just got that is 7.796. So how will we round that? Let's just do 796, comma 80. There's other ways you can round, but let's just do that so we can preserve some of the value. Now, let's answer the first question. The first question is, when the projectile will first reach that height of 80. So the projectile will first reach a height of 80 feet after 0.64 seconds. 0.64 of a second, 0.64 seconds, period. Now, let's answer, that's the first thing. Box. Now, the second thing, and how many seconds later will it again be 80 feet? So over here, we will do 7.796 minus 0.64. So 7.796 minus 0.64, and we get approximately 7.156 seconds. So the projectile will again be 80 feet high after 7.156 seconds. Boom. There you go. I hope you enjoyed, because it's so much fun.